right. Colored pens up. Let's see how we did with this challenging question. What'd you get? We'll start with Dalton, Kadir, and then John.
1 and 1/8.
Okay?
5 over 8.
Okay.
5 over 4.
Okay. So we've got 3 different proposals. Anyone want to jump on and agree with one of those or put in another possible answer? Chris? 1 and 1/16. Okay, so we got a lot of answers that are pretty close to each other. Nobody else? Okay, before I go over the answer, give me a thumbs up if you got any answer at all. Okay, so I still don't know the thumbs up system, but that's okay. Okay, put your thumbs down. Sebastian, what was your answer? What was it? 5 over 4. Matthew? Okay, well, as I've said, you probably heard me say to one of your classmates partway through the warm-up times, there's absolutely no reason to convert to decimal, and you should not convert to decimal. And I don't want you to ever convert to decimal again, unless there are decimals in the original question. But let's reveal the answer. The correct answer is 5/8 of an inch. 5/8 of an inch. Now, was this question in any way easy? Of course not. Am I going to pretend that I expected everybody in the room to get it right this time? No. But what I do expect is that you're going to take the next 5 minutes with me and your colored pen, and you are going to learn, and you are going to digest and understand. Because when you see a question like this again, hint, hint, wink, wink, then you will have a better chance of getting it right. So, this picture is here for a reason. It is a visual representation of all the information given to you in the text of the question. My instructions were, set up an equation and then solve it. So I was very impressed. I walked around, I saw a lot of people setting up equations. That was very good. Some of you even looked like you were on the right track. Some of you didn't really try to do that. You must have been a little confused about what to do. But let's back up all the way to the beginning of the problem-solving process. What have I taught you to look for when you first start trying to solve a problem? Got 3, 4 people who have some recognition. Alexandra? Very good. Janae, did you hear what she said?
Yes.
You did? All the way on the other side of the room? What did she say? Okay, good. So we're going to look for a total. What is the total in this question? Is there a total? I don't even know. What do you think, Stephanie? 11 and a half. What were you going to say, Edgar?
11.5.
Yeah, that is the total. 11 and a half. But 11 and a half what? The total is 11 and a half what? Michaela?
Inches.
Inches. And so what type of concept are we talking about? Are we talking about money? Are we talking about food? What are we talking about when we say 11 and a half inches with this picture in front of us? Kadir?
Measurement.
Measurement. Very good. There's another word that you've heard of, distance. So we're actually talking about a total distance across the paper. So that's the total. And I want you to think about this because I'm actually amazed that more young people and adults alike have so much trouble with the concept of distance. But I am telling you that this distance from here to here is 11 and a half inches. And then I am giving you little chunks that make up that total distance. Here's one little chunk, and then there's another one, and another one, and another one, and another one. So those are little parts of this total. And I am asking you, can you please tell me what will these two chunks be? So, what can I do with all of these chunks? What would I have to do to get the total? What would I have to do with all those pieces? Dalton? Well, that was a great idea since I said the word distance, but that actually applies to something else. And since I've never taught you how to use the distance formula, I wouldn't necessarily expect that you would know how to do it. Michaela?
An equation?
Okay, but I did say, I told you to set up an equation. What type of operations or what would I see in my equation that would allow me to show that all these chunks must equal that big total? Shannon? Yeah, you have to add them all up. If we add this distance, and this distance, and this distance, and this distance, this distance, this distance, and this distance, isn't that the same thing as this distance?
Yes.
So take all the chunks, add them all up, and set it equal to the total. So, where does the total usually go? It usually goes all the way to the... So we've got 11 and a half. And so Shannon was right. We got to add them all up. So we're going to add up 3/4 plus 2 5/8 plus, the next one is x, plus 2 5/8 plus x plus 2 5/8, and then lastly this margin over here plus 1 5/8. Adding all those up must equal 11 and a half. Write an equation and then solve. To be quite honest, I actually expected that many of you should have been able to set that up. So one issue is reading and interpreting the situation. The other issue is, can someone say my favorite word? What's my favorite word, Sebastian? The other issue is fractions. I mean, I'm not going to pretend that this looks easy. It doesn't. But if you're stopping and you just don't know what to do because there's a bunch of fractions, well, then you're not really doing your job very well. I mean, if you think about it, look here and here. So what do I get when I simplify that? My quiet students, stay on your toes because I got too many people tuning out and I got to keep everybody involved. Yes, Alexandra. 2x. So watch what happens when we simplify everything on the left. We get 2x plus, and now we need to add up this, 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 and this. Why make it hard? Why don't we just add up the whole numbers? 2, 2, 2, and 1. 2 plus 2 plus 2 plus 1 is 7. Now let's add up the stuff that we can add up. Well, we've got 5/8 and 5/8 and 5/8 and 5/8. How many 8s do I have?
4.
John? I have 5/8 and 5/8 and 5/8 and 5/8. How many 8s do I have all together? Someone, let's go. John? I have 28s. And then I got 3/4. How many 8s is 3/4? Kadir? 6/8. Well, was that really that hard to do? 5/8 and 5/8 and 5/8 and 5/8 is 28. Then we have another 6/8, so we've got 26/8. Not that hard. So Kadir, when we add it all together, what do we get?
10 and 2/8.
10 and 2/8? You get 10 and 2/8? Sounds about right. 10 and 1/4, 10 and 2/8 equals 11 and a half. I think that's right. How many steps will it take to solve that equation? How many steps, Daniela? 2. So is it really that hard? No. Was it easy? Of course not. But the key was understanding what you were looking for. You have a whole distance, and then you have a bunch of chunks of the distance, and you're trying to find 2 of the missing chunks. Any comments or questions on today's warm-up? Comments or questions on today's warm-up? Concerns? John?
I did sort of the same thing. I did the 6 8 plus 1 5 8 plus 2 and 5 8 plus 2 and 5 8 plus 5 8.
Good.
But I put minus 1 half, and then I got 10 and 1 fourth minus 1 and 1 half, and then I got 1 more. I just didn't put the
Okay. And so it sounds like you had the right idea, but when I ask you to set up an equation implies that there's going to be variables. So, at this level, at least. So, if you're writing something that just has a bunch of numbers in it, then that's not setting up an equation. That's just kind of doing some computation to try and find an answer. Okay? Any questions?
I added up all the fractions, and I got 11 and 4 eighths, and then I subtracted 7 and 7 eighths. I mean, I had 11 and a half, so then I added up all the fractions and got 7 and 7 eighths. So I subtracted that, got 4 and 3 eighths, divided that by 2.
It was a great idea, except adding up all the fractions does not come out to 7 and 7 eighths. It comes out to 10 and 1/4. So you did everything right. You did all the same steps that you would do to solve an equation. You didn't write the equation, but you did all of it. You just missed something. I don't know what you missed, but you missed a fraction, a couple of fractions here or there. Okay? Good. Any other comments or questions? Draw a line across your paper. Today, we begin chapter 4. And so this is where the class changes from kind of an enhanced pre-algebra class to full-fledged high school Algebra 1 honors. This is where the material is all dependent on everything you've learned so far this year and everything you learned last year. So I always start out with a new chapter. I start out with an overview of the whole thing. So we have 3 major goals in chapter 4. There are 7 sections in chapter 4, but we've got 3 major goals. To use linear equations and their graphs to solve some problems. I mean, that's really the ultimate goal of everything, is to be able to solve problems. And we are talking about linear equations. Linear equations only. Secondly, and this is summed up in one sentence, but it's really a lot, is you're going to learn 3 different methods to graph an equation. 3 different methods. So you're going to learn 3 different methods. You have to be able to use 3 different methods. And not only that, you have to be able to determine which method is appropriate for which situation. And then slope. We're going to talk a lot about slope, what it means, how to find it, and how to work with it. So here are a couple of examples of the type of material we're talking about, and I do not need you to copy these down, just look. So on the left you see an equation, y equals 5x plus 70. So we've seen stuff like this already this year, especially the last lesson in chapter 3, literal equations and writing equations in function form. You saw that a lot. What you did not see was the part on the right, this graph. This is a visual representation of this equation. Now, I used a computer program to produce this graph. That's why it looks the way it does. You, with my assistance and guidance, are going to learn how to construct a graph like this by hand. Accuracy is incredibly important. So we use things like straight edges and rulers. If you have your own grade, if not, I can either provide you with one or you can use the edge of a book. We're not measuring, we're just using a straight edge. Putting points on in the right position, incredibly important. Okay? I have another example. Same idea, except this is y equals negative 2x plus 5. And you can see that there's one major difference between the equations and there's one major difference between the graphs. What's one major difference between the two equations if you look at them? It's a major difference. Danielle? Very good. So one is all positive, one has a negative, and what's the difference between the graphs? Just 3 people can make an observation? 4 people? Kadir?
The lines are going in a different direction.
Yeah. You'll notice that this line is going up this way and this line is going up that way. So there is something going on with this and the direction that it's going. You're going to learn about that this chapter. Okay? Caleb.
The bottom equation with the graph, that one is decreasing, right?
Yes. That's right. Very good. So this is an overview of the chapter. Does anyone have any questions? Okay, so now today is a particular lesson within the chapter. So here's the beginning of today's lesson. Today we are going to be studying coordinates and scatter plots. So that is the title of today's lesson. I'm doing something different this year. If you were in my Algebra 1 Honors class over the past 5 years, you copied all of this. This year I'm doing something different. You see in parentheses I wrote, read all terms, copy only the highlighted one. So I am saving you a ton of time and effort, and with good reason. You should know very well all of the terms, with the exception of scatter plot. And I think some of you probably were already introduced to the concept of a scatter plot. But that's what the main focus is today, so I want to make sure you have that down. But I'll be honest with you. Coordinate plane, ordered pair, x-coordinate, y-coordinate, and a graph. You should have no issue with any of these terms. You should know what they are. You should be able to explain them all. And so I don't even think you should be a member of this class if you couldn't tell me what those things are. So I'm not going to have you copy those down. But you have to know them. So what is a scatter plot? Scatter plot is a graph. It's a particular kind that uses real-world data. And we set that data into pairs of numbers. And then what we're really trying to do is figure out a relationship between two quantities or between two values. The science fair tip is coming up soon. You guys are a very advanced group of young people. Some of you are going to do very high-level science experiments. A scatter plot is very appropriate for many of you to do during your experiment. Because what you're doing when you do a scientific experiment is trying to see if there's something happening. If the type of fertilizer I use determines how well my plant grows. Well, that's data you collect, and then you produce visual representations to demonstrate whether or not one fertilizer is better than another, for example. So again, I want to emphasize, I'm not having you copy these because you should already know them and be Jedi Master. You should be Yoda of this. Okay? Does anyone have any questions so far? Okay? Example 1. Plotting points on a coordinate grid. Did you already start writing example 1? Like you were supposed to? Good, now stop. Because we're not going to do example 1. If you were in my Algebra 1 honors class for the past 5 years, we spent 5-10 minutes doing this example. It's a complete waste of time, and I'm not going to do it. Because if you do not know how to plot a point 2, 3, you shouldn't be in this class at all. I'm not trying to make you feel bad if you're looking at this going, I don't know how to do this. I don't mean to make you feel bad, and I'm not trying to say you're a bad person. What I'm saying is you should have had this 2 years ago, and you should be an expert at it at this point. There is one thing that I will go over. When it says describe the location, the publisher is kind of looking for like a description of how many units over and how many units up. I don't really care about that. You do have to know quadrants. You do have to know this is the first quadrant, this is the second, the third is down here, and the fourth is down here. I'm not even going to go over that. You should already know where the quadrants are. And I'm going to be asking you questions on which quadrant is that point in. You should know. If you don't, you're going to have to go home and get some help or go online and try and find a review lesson on it. So we are going to skip over example 1 and go straight to the real work. Example 2. Graph the function y equals -1/2 x plus 1 with the domain -4, -2, 0, 2, and 4. Then identify the range. Now, we have graph paper. Some of you guys struggle a little bit with your handwriting and stuff, and that's fine. But we've got lines all over this paper that we can use to help guide us. So use the lines. If you're having trouble drawing straight lines, then take out a straight edge, a book, a ruler, something to use. Use the edge of your calculator if your calculator has a straight edge. It doesn't really matter. So, graphing the function. We actually know everything you already need to know except for the last step. To graph this function, we need ordered pairs to put on a graph. We have to find the ordered pairs. We already learned how to do this in chapter 1 when you were introduced to functions. You learned how to make this. Excuse me. We're going to make a function table with a small column on the left, a wide column in the middle, and a small column on the right. This is our input, or the x. This is the function. And this is the output, or the y. So that's the function, and we already knew that, but I don't remember what do I do with this information, this thing called the domain and these numbers. What am I supposed to do with that? Because I don't remember, and it's been a while. Jeanette? Very good. That was very well said. Those are my x values. Those are given to me. So they go right here down the x column, and we're going to put them in that order. So it's going to be -4, -2, 0, 2, and 4. And so what I need is the output value, because the input and the output together is what makes the ordered pairs. That's the part that you didn't get in chapter 1. So let's see how this works. This is the part we already know. We take this number, plug it in, chug it out, and get a value. So we've got -1/2 times -4 plus 1. Mental math. -1/2 times -4 plus 1, what do we get? Extol?
-1.
Sorry, you do not get -1. messed up your positives and negatives. Valerie? Do not get 2. I'm sorry you missed a part. Fung? I'm sorry, we're having a lot of trouble with positives and negatives, ladies and gentlemen. Danielle? We get 3. We should not have any issue with this. Negative times a negative is a positive. Half of 4 is 2. 2 plus 1 is 3. Let's do the next one. Negative 1/2 times negative 2 plus 1. What do we get when we calculate that one? Edgar?
2.
You get 2. Very good. Negative 1/2 times 0 plus 1. What do we get for the next value? Matthew? Yeah, you get 1. Would someone or several people like to make a prediction about what the next value is going to be? Davis?
0.
Okay. Well, we think it might be 0 because there seems to be a pattern here. Let's check. Negative 1/2 times 2 plus 1. Yeah, that comes out to 0. So what do you think the next value will be? What do you think the next one will be? Sebastian? Yeah, if you follow the pattern, it will be negative 1, and I can prove it. Negative 1/2 times 4 is negative 2, plus 1 is negative 1. So, you can use patterns anytime you want, but you've got to be very careful. The pattern will emerge if you have the same distance between all your x values. If you have the same distance between all your x values, then you will have the same distance between all your y values. That's for a linear equation. So this is material you already knew how to do. So what you did not realize, or maybe you did at the time, was that you just created a set of 5 ordered pairs. Negative 4 is the x value, 3 is the y value. That's now an ordered pair, negative 4, comma 3. Now, in the past, I've actually asked my students to make an extra column here and write down all the ordered pairs. But I think we're pretty advanced. I don't think we need to do that. I think we're savvy enough to know that each set of numbers is an ordered pair. 0, comma 1, 2, comma 0, 4, comma negative 1. Does anyone have any questions about that? John?
Can you write it like so?
Of course. So now we need the graph. So of course you're using graph paper. That makes it easy. We are now going to make a coordinate grid. You're going to need a straight edge, possibly. I'm lucky I have a powerful computer to help me out to draw perfectly straight lines. And so I'm going to draw a coordinate grid like this. And so to construct a graph of a function, we are going to plot the points. The first point is negative 4, comma 3. So I'm going to go negative 4, negative 4, 1, 2, 3, 4, positive 3, 1, 2, 3. I'm going to make a nice clear point right here. Nope, not right now. Next point is negative 2, comma 2. Negative 2, positive 2. Next point is 0, comma 1. 0, comma 1. 0, 1. Right there. You should notice there's a pattern in the points, in the numbers. There seems to be a pattern in the dots. Let's see if that pattern continues. 2, comma 0. 2, 0. Right there. And then 4, negative 1.
draw a line.
Now, we are not drawing a line through these points yet. There is a reason, and I'm not going to go into great depth about it right now. But if you look at the domain says -4, -2, 0, 2, and 4. Whoever wrote this question, and it wasn't me, I got this from somebody, but who wrote this question is saying that the only input values you're allowed to use are these 5 input values. And it's kind of saying, well, if I draw a line through them, the line represents all the values on that line. So if I don't do this, but if I draw a line from here to here, what that means is that this is also a point on the line. But I don't know if -3 is actually a member of the domain. If I don't know if that's a member of the domain, then I cannot include it on the graph. So we actually, for now, are not going to draw a line between the points. This actually has a name. This is called discrete. There's another type called continuous. You're going to learn the difference over the course of the year. I don't need you to write it down right now. I just want you to hear the word. Discrete. Discrete means that there's individual points. Continuous means a line. Okay? So we are done. This is the graph of this function with this domain. Are there any questions about that? We are also asked to identify the range. So, the range is just all the output values. You already learned how to do this with the squiggly bracket or the brace. And you just list the output values in order that they came out. 3, 2, 1, 0, -1. And that is the range. Does anyone have any questions on how we constructed this graph? Questions, concerns, anything at all? Now, this isn't very scientific. This is very generic. Y equals -1/2 x plus 1. Well, what does that have to do with? Are we talking about economics? Are we talking about population? Are we talking about a scientific principle? Well, we're not talking about anything specific. It's very generic. This is something we do in math class to learn skill. But we learn skills to then apply them to real scenarios. So now the next example, we're going to apply this idea to a real world scenario. Okay? So, example 3. I do not need you to copy the text. I need you to, of course, read it. But the part that you do need to copy is this table of information. So let's read this first, and then we'll copy what we need, and then we'll start our work together. Example 3. The table shows the population in millions and the number of U.S. representatives for 7 states. And the part that I took out is this is actually data from the year 2000. Draw a scatter plot of the data. What conclusions can you draw from the graph? So the goal is really to be able to look at the graph and make a statement about what you see. That's the goal. So let's first look at the data. So across the top row, we've got 7 states. Does anyone know what any of the 2-letter codes are? Can anyone raise their hand and tell me one code and what it stands for? Kayla, give me one of them. Which code is that? Give me the letters. Very good. Can someone give me another one? Stephanie, and then up here. Very good. It is Colorado, not Connecticut. Colorado. Alexandra, and then over here. That is correct. Dalton? That is correct. Very good. Danielle? That is correct. Anyone know any other ones? John? That is correct. Anyone know we got one left, I think?
Yeah, it's
IN, Edgar?
Indiana.
Indiana, very good. So these are 7 of the United States. Now, I don't expect you to be an expert in geography, but you should know off the top of your head that some of these states are large and some of them are small. What you may not have known was that their populations are dramatically different. So you can see that the population in the year 2000 was 4.3 million people in Colorado, but in North Dakota it was 0.6 million. So that's a little over 500,000 people. But look at Texas. That's almost 21 million people. So there's a huge difference between these states. You should be either already learning or you will learn at some point this year in civics how the House of Representatives works. We have 2 houses of Congress. We have the Senate and the House of Representatives. Does anyone know how the House of Representatives works? Like how it's set up? Well, you're actually looking at it. The House of Representatives is based on the population of the state. The more people, it looks, if you look, we have a small number of people, 1 representative. A large number of people, a lot of representatives. So the number of representatives is somewhat based on the population of the state. But we want to see if there's any patterns or anything we can extract from this data. So looking at it right now, the data is not really in any order. It's not like the smallest one is here and the largest one is here. It's kind of all over the place. So what we're going to do is we're going to construct a scatter plot to see if we can extract any patterns or relationships from this data. So you should have the table copied. Now we're going to construct a graph. Now, before you start drawing anything, I'm going to give you some guidance. All of the data in this case is positive. That actually means that our graph can look in a particular way. We actually do not need a full grid for this data. We don't need a full grid for it because all the data is positive. Does anyone know what part of the grid we need to do a graph of all positive data? Sebastian? Quadrant 1, that's right. Quadrant 1 is where we will find all positive points. So we only need quadrant 1. So let me help you and follow along with me. I have to hide that. Let me make sure I have enough space here. We need quadrant 1. So we need the x-axis and we need a y-axis, but we don't really need, we just need a little space to label things. So we've got that part down. Let me extend this for a second. Now we have to plan out our graph. Now, I hope you noticed that I'm taking longer on one question. I'm doing that on purpose because this is the only example we're going to do. You have to learn everything you need to learn from this one example. So we figured out that all positive data means we only need quadrant 1 for the graph. Now we have to determine where this data is going to go. One of these sets, the population or the number of representatives, one of these sets is the x value and one of them is the y. So which one's the x and which one's the y? It has to be one way. You can't switch them around any way you want. One of them has to be the x and one of them has to be the y. Alexander?
The x and the number
Okay, so you think the number of U.S. representatives is going to be X, and that the population is going to be Y. So let me make a counter statement or a counter question. In science class, you learned a couple of words that relate to what we're looking at. Does anyone know the 2 words that relate to what we're looking at that you learned in science class? It's going to be a kick yourself moment because someone's going to say it and you're going to be like, oh, of course. What is it? Well, variable is related, but I'm talking about X's and Y's. Say it again. Yeah, dependent and independent. See, I already got a bunch of people like, oh. So one of these is independent and one of them is dependent. Which one is dependent on the other? So that's my counter question to Alexandra's answer. Caleb? Is what? Yeah, the number of representatives depends on the population. So this is the dependent. And which letter is the dependent?
Y.
Dependent is the output, or the Y value. The independent is the X, or the input. I know that's a lot to take in, but it's actually, we're talking about the same thing you talk in science class, and you'll be talking in other classes. X is input, independent. Y is output, dependent. It depends on this. But that also tells us where it goes on the graph. The population must go on the X. Now, I have to hide the data, so you already have it written down. So now, the last thing that we have to plan out is how wide our intervals should be. In other words, this space right here, what should it represent so that I can fit all my data? So the smallest number of my x's is this. The largest number is this. So what should my interval be? How should I set this up? And this will always be 0. That's 0. So how should I set it up? Only one person has an idea based on all your experience? Oh, now I got 1, 2, 3, 4, 5, 6, 7 people. Extol, what do you think?
3s.
By 3s? Okay, so let's try that out. And let's see. Don't write anything yet. Let's just test it. I won't take one of the decimal. So if I go by 3s, this will be 3, 6, 9, 12, 15, 18. No, we're talking about the x's. But this is good. But 21. Oh, you think we should go by 5s now? Okay, let's try. 5, 10, 15, 20, 25. This will be 25. The biggest number I have is 20.9. So there's absolutely nothing wrong with his suggestion. If he wants to do that, that's fine, but I have a major concern. Look at all this blank space I'm going to have over here. So it's kind of a waste. So anyone have an alternate suggestion? Kayla in the back. By 2s, let's test it out. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So here's my 22, and it's not a horrible graph, but I still have all of this blank space over here.
1.5.
So what do you think I should do to make this look good? Chris?
Have the space for
Honestly, in this case, going by 1s is the easiest thing to do. So we're going to go by 1s. 1, 2, 3, 4. Now let me pause. When you're labeling, as long as you're keeping the interval the same, you don't have to label every point. So watch. This is 4, 5. This is 6. I didn't skip anything. I just did not write down the 5. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then, for me, this graph fits perfectly. Now your graph, I don't know if you left yourself enough space. Maybe you need to adjust. So this is my x-axis. Now let's look at the y values. What's the smallest y value that I have to graph? What's the smallest y value? Valerie? Good. What's the largest y value I have to graph? Stephanie? What is it? That's the largest?
32.
32. So that's actually, but I'm glad you said that because it makes a big difference. Because watch, if I only had to go 1 to 13, then I could go by ones and I could go 0. Well, this is always 0. Put it like 0. This is 0. And then I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and that would be no big deal. But I have to get all the way up to 32. And I don't know if I have enough space to get all the way up to 32. So what could I do on the y-axis to fit everything in? Michaela?
2.
Go by 2s. Let's make sure. I think it's a good suggestion. But so this would be 0, then this would be 2, 4, 6, 8, 10, 12, 14, 16. It seems like it's going to work out pretty well. 24, 26, 28, 30, and I do have a little bit more space up there. 30, and then there's my 32. So that was a pretty good suggestion. So now we plot the points. Before we go ahead and do that, does anyone have any questions on why we set this up the way we did? So now we're going to plot the points. The ordered pairs is each column. Colorado is 4.3, comma 7. Now 4.3 is nowhere on my graph, but I can estimate it. Here's 5. Here's 4. 4.3 is going to be a little bit less than halfway across. And then I need to go up to the 7. So I need to go up to, here is 6. 7 is going to be right there. And so it's kind of floating in between these gray lines, which I'm going to explain in a couple of minutes. But you can get a very good approximate point. Any questions about that? Okay, so now we're just going to plot the rest. 8, comma 13, you can go ahead of me if you are understanding. If not, then just stick with me. 2.7, comma 4. So again, I'm approximating 2.7, 4. 0.6. That's going to be about halfway, comma 1. And that's going to be halfway up this way. 20.9 is all the way over here. Comma 32 is way up at the top. 3.5, comma 5. And then 6.1, comma 9. And that is constructing a scatter plot, real world data. Does anyone have any questions on how I got these points onto this graph? Okay, now again, we don't draw a line through it, but imagining a line actually helps us try to draw conclusions. So watch what happens. I don't want you to draw it, but watch what happens when I do draw a line through these points. If I were to draw that line, that's pretty close to touching every point. So that's something that you have to kind of imagine in your mind. Later on, actually, if you look at the last poster in Chapter 5, Predicting with Linear Models, when we get to that lesson, you're going to learn how to exactly get this line. It actually has a name. It's called the line of best fit. But we want to look at this data and make a statement. Can someone make a statement about what's happening with population and the number of U.S. representatives? That's what we're trying to do, is what conclusion or statement can you make based on what you're seeing in this graph? We'll start with Danielle, Daniela, Edgar, here. Go. Okay, I like that. Okay, same thing.
Same thing.
Go ahead, say it your way. What were you going to say?
I was going to say, as when the population of each state increases, the representatives also.
Okay.
As the representatives increase in population.
Okay, so you said it a little bit differently. Okay, anybody else? Well, here's the real power. We're going to start a new state, Galatonia. And Galatonia is going to have a population of 16 million people.
Where's Gallatin?
How many representatives do you think I will have in the U.S. House of Representatives after we establish this best state ever, Galatonia? Danielle? 25? Let's see. 16 million people. And if we follow the pattern, yeah, I would say that's a pretty good guess, right about there. That looks like it falls right on that line. So that's one thing, that's why it's called, that lesson is called Predicting with Linear Models, because then you can make predictions about what's going to happen in different situations. Okay? Did any of you have a question or comment? Okay, I thought you had your hand up. Are there any other comments or questions? Concerns? We're doing quite well. Draw a line across your paper. Your classwork. You're doing on 2 different pages. You got 4 questions total. You're doing page 31 first. You're going to do numbers 20 and 19. Then on page 30, you're going to do numbers 11 and 10. Please do them in that order. For numbers 20 and 19, there is a graph given to you in the workbook. You just have to copy it down and then fill it in. Yes. All right, pick up your colored pens. Let's see how we're doing. Number 20. There were 2 parts, but really there was actually like 3 or 4 parts. So here was the graph. I gave you the setup of the graph, so really you just had to plot the right points. So shouldn't really have had too much difficulty. It says see above, but I didn't bother copying the part. Is this a function? Yes, it is. You could do the vertical line test. The vertical line test is Take a vertical line. As long as the vertical line never passes through 2 points at the same time, then it's a function. So it passes the vertical line test, it's a function. Any trend you see as the number of subscribers keeps increasing as time goes on. Or you could say, as the years increased, the number of subscribers increased. Anything about increasing and increasing, I will accept. Okay? Number 19. Again, I gave the graph to you, you just had to plot the points. It was a little bit harder because the numbers were so large, you had to estimate where they were. And then you were asked, does it represent a function? Yes, it does. My primary concern is, do you have the graphs correct? And numbers 11 and 10. These were pretty straightforward. Here's the graph. You were asked to identify the range. Here's the graph. You were asked to identify the range. Comments or questions on any of these? Anything at all? Okay, give me a thumbs up if you feel like you are a 7, 8, or 9 right now with this concept. Being honest. Good, put your thumbs down. Good. Draw a line across your paper. Your homework is page 213. You're going to do 4 through 36 even questions only. You must read the next section. Very important to read ahead. And you will have a quiz. Let's see, 4.1, 4.2. Next week, I don't know which day, but you'll have a quiz next week on 4.1 to 4.3.